Hello everyone. Today I'm going to share with you how to go about using prime factorization to solve questions on lowest common multiple LCM. Now this slide may be familiar with some of you if you follow my YouTube video on highest common factors HCF. Okay, this slide shows the natural numbers. So natural numbers are counting numbers. And this slide shows what are whole numbers. Whole numbers are natural numbers, including 0. Right? So whole numbers are all the natural numbers, including 0. And this is a very important slide. It explains what prime numbers are, and prime numbers are very important when we do prime factorization. Right? The word prime is important. Okay, so it is when you do factorization, we are using prime numbers. And what are prime numbers? Once again, prime number is a natural number that can only be divided by itself and by 1. Okay, so can only be divided by itself and 1, and the least is provided there. And the second rule is that a prime number has only 2 factors. Okay, so 1 and the prime number itself. Okay, so for example, factors of 13. 13 is a prime number, so the factors of 13 are 1 and 13 only. Okay, now in primary school, P4, right, to be exact, in primary 4, all of us have gone through P4, and we know that P4 we learned about common multiples. Okay, and common multiples is simply known as the times table in that sense. So we just need to list the times table of a particular number that we are asked to find. So for example, in my question A, we are supposed to find the multiples of 9 and the multiples of 12. So what we can do is we can list the multiples of 9 using the 9 times table. So I'm going to do listing now. So the multiples of 9 is 9, 18, 27. Okay, so how do I get all this? It's very simple. 1 times 9, 9. 2 times 9, 18. 3 times 9, 27. Right? 4 times 9, 36. 5 times 9, 45. And the least continue. Right? The least continue because it is endless. It is infinity. Right? So I've already listed the multiples of 9. Next, I'm going to list the multiples of 12. So the multiples of 12 is the same way. It's a 12 times table. So 12, 1 times 12, 12, 2 times 12, 24, 3 times 12, 36, 4 times 12, 48, and the list continues. It's endless, it's infinity. Okay, so I've already listed multiples of 9. I've listed multiples of 12. All right, so we normally don't list too many. All right, we will stop when we encounter the first common. So the first common, if you compare the list of 9, the list of 12, we arrived at number 36. And 36 is the common multiple of 9. Okay, so this is the first common multiple. The first common. Now, if you continue some more, all right, so okay, I'm just continue for explanation's sake. Okay, so I'm going to continue multiples of 9. Okay, so what do I have? 1, 2. Okay, after 45 will be 54. Okay, after 54 will be 63. After 63 will be 72. And after 72 will be 81. And the list continues. Okay, so I'm going to stop at 81 because I have lack of space. Now, how about multiples of 12? 48. The next one will be my 60. Followed by my 72, and I continue from that. Now I stop at 72 because 72 is another common. And this 72, which is common, is not the first common anymore. It is the second common. right? It's a second common multiple of 9 and 12. So in actual fact, all right, if we are asked to find the common multiples of 9 and 12, okay, we can simply use 36. Okay, that means we just need to use 36 to find the multiples of 36. So when we find the multiples of 36, we have already gotten the answer. Okay, all right, so let me explain clearly for you. So if I find the multiples of 36, so 36 will be the first multiple, 1 times 36, 36, 2 times 36, 72, and with the list continue. Alright, if I continue, I'll get the third common multiples of 9 and 12, which is the third multiple of 36. Alright, okay, that's what you should have learned in P4 common multiples, primary school math. Now, for secondary school math, common multiples can be found in a different way using what we know is called repeated division method. Okay, so I'm going to show you repeated division method, but repeated division need to use prime numbers. Okay, so let's recall what prime numbers are. Prime numbers are numbers which can only be divided by itself and by number 1. So 2 can be divided by itself and number 1. 3. Now 4 is not a prime number because 4 can be divided by 2. Alright, 1 and 4. So there are 3 divisor. So 4 is not a prime number. 5 is a prime number. Alright, 6 is not because 6 can be divided by 2, 3, 1, and 6. 7 is a prime number because 7 can only be divided by 1 and 7 itself. Okay, 8 is not, 9 is not, 10 is not, 11 is. Okay, and the list continues because it's lead to infinity, it's endless. Okay, so I'm going to show you how to go about using repeated division, okay, to solve, to find the first, okay, common multiples of 9 and 12. I will omit A because A is the same method as what we did just now using the P4 way of solving. Okay, so I'm going to do the repeated. Alright, let me write down for you. We are going to do repeated division to find the common multiples of 9 and 12. Okay, alright. Okay, the first common multiple, this one. Okay, now repeated division is a very interesting way of writing the notation. It is the upside down division symbol. Okay, in primary school, our division symbol looks like this. But for secondary school repeated division, the symbol is the upside down one. Okay, let me show you how it looks like. Okay, I want to clear this part. I want the space. Okay, so what we do is we write down like that, 9, comma, and 12. So we write both side by side and we write down the symbol. So it's the upside down. Okay, you can write in this way, like a perpendicular lines, or if you want, you can also write this way with a curve. All right, it's an upside down division notation. Okay, now we all know that 9 and 12 cannot be divided by 2, right? So together they can't, but for common multiples repeated division using prime factorization, we can actually entertain the numbers separately. Meaning, we look at 9 and 12, right? We know that one of them can be divided by 2 because one of them is an even number. So that is number 12. So we put 2 here. Okay, 2 is the divisor. Now, 9 cannot be divided by 2, so we just ignore. We just bring the number 9 down. Okay, just ignore, bring it down. Now, let's do 12. 12 divided by 2 can. The quotient is 6. So we do the next division. That's why it's called repeated division. Our aim is to keep on listing, keep on doing repeated division until we arrive at number 1. Okay, for both numbers. So we do them concurrently. Okay, now looking at 9 and 6, I think we can still do 2. So the divisor can still be 2. So again, 9 cannot be divided by 2 because 9 is odd. We are not allowed to have a remainder. So 9 is odd, so cannot be done. So 9 bring down, no treatment. Okay, 6 can be divided by 2. We get a 3, which is a quotient. Let's proceed. Now, 2 cannot be divided anymore. 2 cannot be the divisor anymore because 9 and 3 are odd numbers. So 2 is settled. Now we move on to the next prime number, which is 3. Let's do 3. So 9 divided by 3, yes, it is 3. The quotient is 3. And 3 divided by 3 is 1. Okay. So we arrive at 1 here. Okay, so we managed to end at 1, which is very important. Okay, so when we do repeated division, prime factorization, we always need to end at 1. Okay, all right, now we have to continue some more because our aim is to get both 9 and 12 to end at 1. So next repeated division, 3 again, we get 1 and 1. Congratulations. So remember, repeated division, prime factorization, you only stopped when we arrive at 1. Okay, that means there's no more division can be done further using prime factorization, repeated division concept. So what do we have here? In our list of divisor, we have 2 appear twice. Okay, let me write down 2, 2, 3, and 3. Now, what is that list all about? It's actually, you can write them as a product of factors. Okay, so 2, 2, 3, 3 is actually all the 4 divisors there. You just multiply them together, form that as a product. What do we get? We get 2 times 2 times 3 times 3. Okay, so what happened is 2 times 2, if you remember what we did previously, 2 times 2 is actually, okay, let's go back to P5, order of operation. 2 times 2 is 4, 3 times 3 is 9, right? So 4 times 9 is 36. And if you remember our previous slide, the primary 4 method of doing common multiples, yeah, the first common multiple of 9 and 12 is indeed 36. So we have obtained the answer. Okay, all right, now I will show you in my next slide how to write this using index notation. Okay, so this one is omitted because this one is done in P4 using P4 way. All right, now this one we have already gotten our answer. It's 36, right? So 36 is our answer, is obtained from 2 times 2 times 3 times 3, right? Okay, now this is one way of writing, but in secondary school, we are always asked to write our answer using index notation. Okay, index notation means we have to use our idea of power. Okay, so 2 times 2, the 2 appear twice. So 2 appear twice means 2 is to the power of 2. Okay, then this 3 appear twice, so it's 3 to the power of 2. So this expression can be written in this way using index notation. So 36 is equals to 2 to the power of 2 times 3 to the power of 2. It can also be read as 36 is equals to 2 square times 3 square. It's the product of factors of prime numbers using index notation. Okay, let me write down what I've just said so that it's clearer for you. It is the product, okay, of prime numbers using index notation. Okay, right? Okay. Now, Let me do a quick comparison between the two levels that we have done, mathematics, primary math and secondary math. Now, in primary math and secondary math, they have used the common term called common multiples. In primary math, we always mention first common multiple. But in secondary school math, the word first is replaced by the word lowest. That's why the acronym LCM is arrived. Okay? Alright, so in primary school, we call this first common multiple, which is number 36 in our example. And in secondary school, we call it lowest common multiple. So the LCM is 36. Alright, I hope you find my video on LCM using prime factorization useful, clear. Okay, now stay tuned. I will be sharing with you HCF and LCM using prime factorization. That means I'm going to show you both by using a GCE O-level question. Okay, so I'll be using one particular year's question to explain to you how to go about using prime factorizations and index notation to solve a question involving LCM and HCM. In other videos, I'll be talking about square roots and cube roots. Everyone, if you like my today's explanation on LCM using prime factorization, don't forget to like my video. I strongly encourage you to give me your comments, okay? Feedback, motivation, your comments, yeah, they are all valued by me. And do remember to share, all right? Share my video with friends who are interested. And most importantly, do subscribe. Because when you subscribe, okay, you'll be notified that there are new videos from Joseph Math Academy. Okay? Alright. Thank you for watching this video. I want to thank you for your support. Thank you for supporting my YouTube channel. Do stay healthy, stay safe, and stay tuned. Yeah, you'll be notified when I have new videos being uploaded. This is Joseph. Goodbye.